This problem is asking us to graph f of x equals 5x, the inverse of f of x, log 5 of x, and g of x, a transformation of log base 5 of x. It's also asking us to include 4 points for each graph. So I'm going to start with f of x equals 5 to the x, and I'm going to plug in points for x and y. I like starting with 0. So I get 5 to the 0 is 1, 5 to the 1 is 5, 5 squared is 25. That looks like it's getting a little bit big for my graph, the y value, so I'm going to go with -1, which is going to give me 0.2, or 1/5. So those are my 4 points for f of x equals 5 to the x. So I can get those on here. Got 0, 1, and 1, 5, 1, 2, 3, 4, 5. And then -2 to the 25 is going to be something like way up here. And then -1 to the 0.2 is going to be somewhere down here. So I'm going to get a graph something like this. Apologize for the imprecise tool of the stylus. Then I want to do my inverse graph of log 5 of x. And I'm just going to make an inverse table. So 1, 0, 5, 1, 25, 2, and 0.2, -1. Just plot those points. 1, 0, 5, 1, 25, 2 is going to be way out there, and 0.2, -1, somewhere around here. And my inverse graph is going to look something like this. And I can check that and see if I have my line y equals x. Is that a reflection? And yes, it is. So then I'm looking for my transformation, where everything is going to be shifted to the left 10, up 5, and it's all going to be vertically expanded by a factor of 4. So one of the things that I can start doing is looking at my table for g of x. I need my 4 points. So I know everything is going to shift over to the left 10. So I'm going to do 1 minus 10 is -9. 5 minus 10 is -5. 25 minus 10 is positive 15. And 10 minus 2 is going to be 9.8, -9.8. So those are my x values. Now I have to consider that all of my y values are going to be shifted up 5, and I also have this this here of this vertical expansion stretch of 4 as a factor of 4. So if I have this point at 0, 0 plus 5 is 5. So we know that that's probably a pretty good dot that's going to stay there. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, up 5, 1, 2, 3, 4, 5. We know that because if we have x equals 10, -10 plus 10 is 0, and I can't really have 0 as my log. So we're going to look at -9. 10 minus 9 is 1. Log base 5 of 1 is 0. 4 times 0 is still 0. And 0 plus 5 is 5. So we can check that that point is good. So next, let's look at what happens if we put -5 in. -5 plus 10 is going to be 5. and base 5 of 5 is 1. 1 times 4 is 4. 4 plus 5 is 9. So we know we're going to have a point at negative 5, 9. So we're not just moving things up, we're multiplying it by 4 and then moving it up. So 4 times 1 from here is 4, plus that 5 gave us this 9. So if we look here, we're going to go negative 5, and we're going to go up to 9. Alright, so we can continue going this way. If I have a negative 15, or positive 15, sorry, in here, that's going to give us 25 log 5. Log base 5 of 25 is 2. 2 times 4 is 8. 8 plus 5 is 13. So we know that we're going to have this spot at 15, 13, which is going to be kind of up here-ish. And then our negative 9.8 is not something that kind of fits in here nicely. So let's kind of look at the pattern. That comes from this point 2, which was at negative 1. So negative 1 times 4 is negative 4, plus 5 is 1. So we're going to expect we're going to be somewhere down here. So our logarithmic graph ends up transformed looking like that.